Hi everybody, here we're going to do an exercise to learn how to calculate vector components, but here you'll be able to see it in a picture. So let's say that we have this vector here. Its length is 10 units and it's oriented 36 degrees relative to the positive x-axis. So try to calculate the x and y components for this vector. Calculate using cosine and sine. So let's double check to see what the answer is. So if I show the components, you can see here that the components are showed here. So let's double check here. So the x component for this vector of length 10 at an angle 36 degrees should be 1, 2, 3, 4, 5, 6, 7, 8 units in the x direction. So that's going to be 10 times cosine of 36 should give you 8. And in a y direction, it's going to be 1, 2, 3, 4, 5, 6 units. So that's the y direction. So the y component of this vector, which is going to be 10 times sine 36, should give you 6 units. And let's just double check here. So you can see right there that given the magnitude of 10 degrees and an angle 36 degrees, the x component should be 8 units and the y component should be 6 units. Now let's calculate the x and y components for this vector that has a length of 13.6 units and is oriented 144 degrees relative to the positive x-axis. So to calculate the x component, you would do 13.6 multiplied by the cosine of 144, and pictorially you can count what it gives you. It's going to be, these are 5 squares, another 5 squares plus 1, so you should get an x component of 11 for the x component for the vector. But one more thing is that it's pointing backwards, and this is along the second quadrant. So if I put the axis here, so you can see that this vector points along, it's in the second quadrant, and so because of that it points along the negative x direction. So the x component should actually be equal to negative 11. And let's try the y component for this vector. So to get the y component, you would do 13.6 multiplied by sine of 144, and just you can count directly from the picture to see how many. So these are 1, 2, 3, 4. Well, let me just count this way. So these are 5 squares, and then plus 1, 2, 3. So you should get 8 units for the y component for this vector, and since it points upwards, it's going to be a positive y. So let's just verify that. So you can see here that this vector, its x component is given by 13 cosine 144, and that should give you negative 11, or 11 squares backwards. And the y component for this vector should be 13.6 multiplied by the sine of 144, and that should give you 8, or 8 squares up, or positive 8, or 8 squares going upwards. Hi everyone, so here we're going to do the reverse exercise. We're given a vector and we're given its x and y components. So its x component is 1, 2, 3, 4 horizontally, and in a y direction it's 1, 2, 3, 4, 5, 6, 7, 8 units. So go ahead and try to calculate two things: the magnitude of this vector and also its direction. And then we'll double check in this picture. So first, let me just show you what I have here. So its angle, you should have gotten a direction of 63.4 degrees relative to the positive x-axis, and the magnitude should come out to be 8.9 units. So to get this to get the magnitude of 8.9 units, you should have used the Pythagorean theorem applied to so square root of 4 squared plus 8 squared, and to get the angle of 63 degrees, you should have used the inverse tangent of 8 divided by 4. So now let's try to calculate the magnitude and direction of this vector. So this vector has an x component that is backwards at negative 8, and has a y component that's upwards at a positive 5. So go ahead and try to find the magnitude and the direction of this vector. So let's double check the answer. So I'm just going to put the angle here and also the answer. So the magnitude of this vector, you just have to use the Pythagorean theorem like before. It would have been the square root of 8 squared plus 5 squared. That should give you 9.4. The direction, though, that one might be a little tricky. The actual direction that you want, if I put the origin here, this vector points it's in a second quadrant. So this vector, this angle, this axis points at 180 degrees, and this angle here points at 90 degrees. So the angle that you want should be between 90 and 180. And in your calculator, you may not get that directly from your calculator. So what I always recommend that you do is to ignore the signs of the components and calculate the inverse tangent of 5/8. And once you've done that, then you have to consider the quadrant that you're in. So once you calculate the inverse tangent of 5/8, the quadrant that you're in the second quadrant. So you want your angle to be bigger than 90 and less than 180. So you would, once you get the inverse tangent angle, then you would plug that into 180 minus. You would subtract that by 180, or you would subtract 180 by that angle.